Welcome to geometry, and today we look at our final rigid motion. We look at translations. So now, what is a translation? Well, a translation is just a slide. So we have a pre-image here. Here's our triangle, and it consists of 3 points, P1, P2, and P3. But you also are going to need a vector. Here's our vector AB. A vector simply tells us our direction and the length. So notice that the direction here would be downwards, okay? And a little bit to the left. So you're going to take this triangle and move it downwards by this much, okay? By vector AB. And so here are the steps to do that. Step 1 is to measure the length of the vector with your compass. Okay, so let's measure this length here. Take compass and measure the length. There's the length. Step 2 is to place the needle on a pre-image point. Do not change the size of your compass. Okay, so using the same size, I'm going to use P2 as my pre-image, and I'm going to make an arc in the direction of the vector. So I want to make an arc down here. Okay, I do not want to make an arc up here because that's not the direction of the vector. Or here, or here, or here. I want to make it down here somewhere. Okay, so let's make an arc right around there. Step 4, measure the distance from your start point to your pre-image point. So the starting point of the vector is here, and I want to measure the distance from there to the pre-image point. So let's measure this distance. Okay, that's my distance. Step 5, using the distance from step 4, place the needle on the arrow and intersect the previous arc. Okay, so let's place the needle without changing this distance. Let's place the needle on the arrow of the vector, and let's intersect the previous arc that we already have. So here's the arc that we already have, and let's intersect it. Boom. There we go. That point is P2 prime. So let's repeat these steps for the P1 and P3. And so here we have it. Okay, notice that we slid down by a direction of AB and the length of AB as well. That is our vector. Our vector describes distance and direction. Okay, in this example, our vector is AB. So what are some things that we notice about this translation, about this transformation? Okay, well, first, these are the 3 properties of a translation. It maps lines to parallel lines. Notice that P1, P3 is parallel to P1, P3 prime. So is P2 prime, P3 prime to P2, P3. These are all parallel. All we're doing is sliding, and when we slide, notice that when you slide, lines are going to be parallel. They're going to be parallel. Now, these also preserve angles, right? Which is true about all rigid motion. This angle is going to be congruent to this angle. They're corresponding. So we know that corresponding parts are congruent when we have a rigid motion. Here's another angle that is congruent to this angle over here. And last, they preserve length distance, which is also true about all rigid motion. Notice here, I can slide P1 and it will land right on top of P1, P2, right? Because they are going to be congruent. Similarly, if I slide this one over, they should be about the same size, okay? Now, sometimes they may not be perfect because things can go wrong, especially when we're measuring. So, okay, we can also translate using points, okay? In this, here's the notation for translation when you want to translate in the coordinate plane or outside of the coordinate plane. In general, your notation is going to be capital T and then some sort of coordinates to describe your vector. In this case, it's saying 4, -7. So this means that x is going to go to the right 4 units because that's positive in the x direction, and down 7 units because that's negative in the y direction. And so let's first translate point C, okay? Point C is at 4, 2. What we need to do is shift left 4 units and down 7 units. So if we do that, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Right here is going to be our point C prime. Now I'm going to do the same thing to find A prime and B prime. So here are my 3 points, and now I want to connect all these segments to construct my triangle A prime, B prime, C prime. There's my triangle A prime, B prime, C prime. 3 properties should happen. Remember the 3 properties? Okay, well, let's slide this bad boy up here, and hey, look at that. They are exactly the same size. That means that the angles are the same and the side lengths are also equal. Okay, congruent. And you can tell that these lines are parallel here. Notice that they're parallel, parallel there, and parallel there. So all 3 pairs of corresponding sides are going to be parallel. And now let's look at our final example here, okay? So here it says, describe a sequence of rigid motions that would map triangle ABC into triangle A prime, B prime, C prime. So here's triangle ABC, and we want to get it to land on here. So there's one way that I've already done for you. In this case, I want to first translate, right? I want to translate 3 units to the left and 4 units up. And so in vector notation, that would be 3 units to the left would show -3, and 4 units up would show +4. Okay, so let's slide this bad boy in that direction. And so there are my 3 points, okay? There's my A prime, my B prime, and my C prime. There they are. And now I'm going to reflect now because I'm still not here. Now I need to reflect. So let's actually flip this to the left, right? And so we will be right there once we flip over, reflecting across the y-axis. Now here is your CFU, okay? Find and plot the coordinates of B prime, So here's B and here's segment AB. I've already done A prime for you. And you need to find B prime and state the coordinates. And then what is the relationship between segments AB and segment A prime, B prime? And explain. That is all. I'll see you tomorrow.